What is up, everybody? OGP back with you for a fun adventure video today. I've got the dumpster diving driving machine all cleaned out, fueled up, and we're ready to hit the road. We are going to tour NASA. NASA in Pasadena, California. Better yet, it's called JPL. It's the Jet Propulsion Laboratory. They have the Mars Rover, all kinds of different space projects and stuff going on over there. We are going to go check that out right now. And we might even encounter some aliens. Who knows? Alright, well, we have made it. We are at the Jet Propulsion Laboratory, the NASA facility here in La Cañada, Flint Ridge, California. We're going to check in just a minute. We got security over here, big old parking lot back there. And we came, and we're now at the visitor center reception area where the tour will begin. Very excited to get in and check this place out. And we're now official. We got the badge, the tour badge. JPL right there, going in. Actually looks like it's gonna be a pretty big tour. Plenty of people here coming along with us today. But we're right here at the beginning of the line, waiting to venture into NASA here. We've got a NASA truck over here. We've got that JPL truck right there.
Security. NASA.
Weirdo. I'm touring with these weirdos right here.
Weirdo.
And we're off. The tour has begun. Look at this little guy right here. The IT petting zoo. Coming into a building here, our first building. Look
at the connectors and everything. This was a structural test model, so we put this on a shaker and shook it with what we expected the environment.
Like a rocket thing over there.
Make sure it wasn't going to break apart.
Oh wow.
Okay, so you guys can find a seat. You refer row back. We just ask you kind of go to the edges where you're as you move closest.
Wow, look at that thing.
So JPL stands for Jet Propulsion Laboratory. We are a NASA center. We are one of 10 NASA centers. And we have a very unique beginning. So it all started because there was a couple guys in Pasadena, Jack Parsons and Ed Foreman, that were experimenting with rockets in their mom's backyard. So they're kind of just shooting them off in the arroyo. And they attended a Caltech lecture on rocketry and thought what great things can happen if they combine forces. So they went back to Caltech a couple days later, brought some of the things they were working on, and asked them about working together. So they had met with Dr. Theodore von Karman, professor there, who is a little busy at the time, so he kind of put them in touch with one of his head graduate students, Frank Molina. That's essentially how JPL was born. So these group of 4, 5, 6 guys got together and they started experimenting with rockets. Now, they were doing some of their experiments on the Caltech campus, and as you can imagine, when you first start anything, a lot of things can go wrong, especially when you're combining different chemicals to make rocket fuel and you're working with rocket motors. So the stories go that when they're experimenting on the campus, they're almost setting buildings on fire. They're setting parts of the test equipment flying into the wall, projectiling. They were making these smells that were so bad it was making the students nauseous as they walked around to their own classes. People ended up nicknaming them the suicide squad, so it kind of tells you what was going on. The funny thing was Caltech was okay with them kind of injuring themselves, but they didn't want them to hurt anybody else along the way. So they said, keep doing what you're doing, you're learning a lot, just do it somewhere else. And that's when they came to our current day location. So as you can imagine, the mid-1930s, forgot to mention the date, mid-1930s, around here, so close to the mountains, there wasn't really anything here. So it's a perfect place to do these rocket motor tests. So they weren't the full-on rocket tests, those were done out in the desert. It was a rocket motor test, everything was staked down to the ground, nothing went flying around. But they did their initial tests here. So Professor von Karman was working with the U.S. Army, traveling back and forth to the East Coast, and was telling them about the work with rockets that these guys were doing here in Pasadena. So obviously at that time in the mid-30s, that was of great interest to the Army. So they actually gave funding to what was JPL at that time. So about 20 years, we were working with the Army designing, developing missiles and rockets. So we created the JATO rockets. That stands for Jet Assisted Takeoff. Those are for the heavy airplanes that were running off the short runways in the South Pacific or dirt runways. So they're essentially two rockets stuck on the wings that would help them get into flight much faster. They're also working on a series of missiles. Luckily, they were not ready for use before the war ended, but they were in that process of designing and developing those. Fast forward to 1957, the Soviet Union sent the first artificial satellite. What was the name of that satellite? Sputnik. Good. So Sputnik orbited planet Earth, and it beeped as it went around, so we knew, in fact, it was going around our planet. Now, at that time, it was kind of a scary time here in the United States, because the Soviet Union was not exactly our friend at the time, and we didn't know what they were going to do with that knowledge. Were they going to attack us, or were they going to spy on us? What was going to happen? So there was a rush here in the United States to send our own satellite up and prove that we were just as powerful of a nation. There are two groups that were competing for that first attempt. So here, still with the Army, was one group working on Explorer 1, and then the Navy was working on a group called Vanguard. Now, Vanguard was the selected mission. JPL was not the selected mission. We were specifically instructed not to build a satellite. So when Vanguard, they were rushed to the launch pad after the success of Sputnik by the president, the pressure to go to the launch pad. They weren't quite ready. They hadn't had a test launch yet. And the rocket went up a couple of feet and came back down the ground and caught on fire. So here in Pasadena, we saw that as our opportunity to send our satellite up. Now, we had secretly been building one, and I say secretly because we were told not to. And when they would come make sure we're following orders, they would hide pieces of the equipment in car trunks and in closets. I know Frank Molina was saving a rocket, but he told everybody he was testing the shelf life of a rocket. So he said, I want to put it on the shelf and see how long it can sit there and then still function. But secretly, he was hoping to use it for Explorer 1. So with the failure of Vanguard, we saw that as our opportunity. So we went back to the government and said, we can build one really fast. But in reality, we just needed to finish up what we had already started. And on January 31st, 1958, Army with JPL sent up Explorer 1. So Explorer 1 was the first time that a science instrument was sent up into our solar system and Earth's orbit to learn more about our planet and beyond. So it really kind of launched us into that age of space exploration. Now, the name Jet Propulsion Laboratory is kind of funny. There was no official naming ceremony. It just sort of appeared on some paperwork in the mid-1940s. Even with the success of Explorer 1 in 58, all the newspapers read Caltech satellite successful, Explorer 1, all of that. Now, the name Jet Propulsion can be a little misleading, but the reason why they chose those words is because at the time, the word rocket wasn't a respectable word. So if you said you worked with rockets, people would laugh in your face. They wouldn't take you seriously. They would think Buck Rogers, Hollywood, special effects, all of that. But when you have a rocket go up, you have a flame come down at the bottom. That's called a jet. So if you said you're working on jet propulsion, which is pretty much the same thing, now all of a sudden people started listening to you and taking you seriously. So that's where our name Jet Propulsion comes from. And we've kept it even though we no longer do that.
Of all the places in the world,
He sounds like
I
a
believe
rocket
JPL
scientist.
is the single best place to visit if you want to learn about robotic exploration of space. The lab got its start when a group of rocket enthusiasts and students at Caltech undertook a series of rocket experiments.
That was 1936. By the 50s, we were building rockets like these. Then, in 1958, in answer to the Soviet Sputnik, JPL built and helped launch the first U.S. satellite, Explorer 1.
Since that time, JPL has been our nation's premier center for the robotic exploration of our solar system.
We also operate the Deep Space Network, the vital communications link that allows us to send commands to and receive data from an armada of spacecraft.
Not a day goes by that JPL isn't involved in some new discovery, and we share that information with the public and our schools.
It's a privilege to conduct space exploration on behalf of our nation. We hope you come away understanding how the passion of our employees and their spirit of exploration motivates everything we do. We thank you for coming, and we hope you enjoy your stay.
Has separated where we found the ground expanse tone. Standing by for batch cell separation. We are in powered flight. Standing by for stack crane. Stack crane instruction. We're safe on Mars.
One is the farthest, and Voyager 2 is the oldest man-made objects out in space. Most of the instruments that you see represented over here have been shut off, including cameras. There's nothing to take pictures of, and there's no light to take those pictures, so they conserve power and shut them off. Now, earlier I was talking about the fact that because we don't send astronauts out into space, we're less limited by distance. One of the good things is, if you send a human out, you have to give them food and water and air, all of that. When we send our spacecraft out, we have to protect them from the harsh environments out in space. One of the ways we do that is with thermal blanking, so the covering that you see on here and on the Voyager, all of our spacecraft, you'll see gold or black, that's called thermal blanketing. So thermal, we think thermometers measure temperature. This helps regulate the temperature for our spacecraft.
First off, what we're looking at right here are the very first two versions of the rovers we sent to Mars. The very first version of rover we sent to Mars is actually a small little one you see on the opposite side. You might better know it's a Pathfinder mission. It landed on Mars in 1997. That is a full-scale model of the rover it had. It was referred to as Sojourner. So that's the same size as Sojourner. That's full scale, but that is strictly only a model. There's nothing on the inside. It doesn't move, but it gives you an idea of how large it is. Now, that was a technology mission. Basically, we wanted to prove that we could actually remote control a robot on the surface of another planet from here on Earth. Because prior to that, we've never actually done that. So we wanted to prove we could actually do that. So that's what we refer to as a technology mission. The room is set up in the proper order of the solar system. At each planet, there's a marble, kind of like the one Brian's pointing to right there. You guys see that he's pointing out? That's supposed to be Mercury. If the sun is as large as that picture behind Brian, then Mercury is as small as that little thing he's pointing to right there. Thank you, Ryan. And as you make your way around the room, you're going to see the other marbles to give you an idea of how large those planets are compared to each other, compared to that sun. By the time you make it down to Jupiter, you'll notice it's about the size of a basketball. So right now, feel free to look around. If you have any questions, you can come up and ask questions. If you would like to watch that video, you can come here. I'm sorry. You can come to the center of the room, take seats.
Look, that's what happens when you keep touching it.
Yeah, you're right.
Alright, well, we just ended the video in the other room, and we came into this room where there's all kinds of objects around. We've got right here an actual moon rock. We got a piece from the moon lander that was testing the samples of the surface of the moon. Over here we got a model of an actual size model of one of the Mars rovers right here. And then up there, part of the spaceship that stretches all the way to the other side of the room over there. And then, like they were saying, this is a big image of the sun here. So if that was the size of the sun, this is the size of Mercury right here. A little dot. And then you got the Mariner 10 spaceship here, and there's a model of that orbited Mercury. And you got the Magellan here at Venus, so that's the size of Venus right there compared to big old sun over there. The Magellan spacecraft. There's the Earth. So you see Venus and the Earth about the same size, but tiny compared to the sun. Very cool place here, very cool. Alright, well, we've left that place, very cool stuff in there, and now we're heading to mission control.
Curiosity weighs close to 2,000 pounds. It's about the size of a Mini Cooper. And this rover is made mostly from aluminum and titanium. Now, the temperatures on Mars are quite cold. During the day, you'll have temperatures reach 50 degrees Fahrenheit. At night, you can have the temperatures drop down to 150 degrees below zero. Okay, so you're going to want to make sure that you select materials that can withstand that thermal cycling or that temperature change. If you look at the wheels of the rover, they look like they are rubber, but listen carefully. They are aluminum. Okay? And the wheels have been anodized, which gives them that black color. The arm will extend out, drill into the rocks. It will collect a very small sample. We then take that material and bend the arm backwards and deposit the material inside of the rover. And the rover has a chemistry lab on board, so it can do the analysis for us. It can look at the mineralogy of the material, look at the chemical makeup, and essentially this is our scientist on Mars. So that's why this rover is so much larger than the previous generation of rovers that we sent. On the head or the mast of the rover, you'll see multiple cameras. Those cameras are in pairs, so that this rover has depth perception. It can gauge distance, and that's very important. You don't want to accidentally run your rover into something or drive it off a cliff, so it needs to be able to gauge distance. The large lens that you see on the head of the rover is a high-powered laser. Now that laser can fire up to about 30 feet away. As it fires at the rock, it burns the rock, releases a vapor. That is showing you the most recent images that Curiosity sent back to us. So this rover likes to take selfies. That's a good thing. By the rover taking photographs of its body and chassis, we can make sure that there is no damage to the rover. So you can go onto our website and always see those most recent images that the rover has sent us. And then over to the left, you'll see a light display. You will see the name of a spacecraft come down in the center. If you see lights traveling down at this very moment, we are receiving data from the spacecraft. If you see lights traveling upward, we are sending instructions to the spacecraft. And the volume of lights indicates the amount of data being exchanged. And that's high-density mission control.
Here we go, going upstairs now. There's like equipment here, like emergency equipment or something. The red phone. The red phone. Don't touch the red phone. Spaceflight Operations Facility. There we go. There it is, right there.
Right this way, folks. We're gonna come back down.
Going
Nice. What?
in here.
Do.
Oh, check this out. We're going in mission control. Gotta be quiet, Austin.
Right down there, folks. Make sure sit in the first couple rows. Take up every seat. Thank you. Go ahead and have a seat, folks. I'll give you plenty of opportunities to come up and take photos at the end. Go ahead and have a seat. Anywhere you like, first couple rows, first 3 rows. Watch your step. I'll give everybody an opportunity to step on up in a second, but go on up, have a seat.
Deep Space Network right there.
Go ahead and have a seat, folks. Now, JPL's main task with the moon, with our moon landings, before the Apollo mission, were the Ranger missions. It's proof of concept. President Kennedy says we're going to do it. We have to prove that we can do it. Now, the Ranger missions were just to hit the moon. That was the task. We had to send a rocket up and hit the moon. We failed the first 6 times. We had launch failures. We missed the moon twice. It's right there. You guys can see it every night when you go to sleep. The moon's up there. And then Ranger 6, we're pretty sure it hit the moon, but the camera didn't turn on. So we didn't have any proof. NASA was looking down on us, who weren't too pleased with us. So we had to make sure everything was perfect for Ranger 7. Ranger 7 was a complete success. Got a lot of photos of the moon. Everything worked beautifully. And all of our scientists were very excited, and the engineers, and they all went back to their work, and nobody could figure out what we did differently. All the data we had, nobody could put their finger on anything that we had done differently. The only difference anybody could figure out is over there. That when you guys step up, you'll walk over that room where everybody was jumping up and down when Curiosity landed. The guy hit the lanyards in his face, that whole thing. In that room over there, one of the engineers, the chief engineer, brought a bag of peanuts and was sharing them. And that was the only difference. Now, we are a bastion of logic and reason. We cannot believe in a superstition. However, we now have a tradition. You see it behind. Jay Leno's holding them up right there. We have lucky peanuts at every launch.
All right, well, that concludes the tour. We're going to go in and check out the gift shop.
B-A-R-G-E-R. Oh, I could tell you all about it step by step. It's just a process. I have no idea how it is.
Sitting down at the table. You need to get up.
I actually want to share your t-shirt.
Like mine?
Yeah, but like the white. Oh, yeah. Way too small.
All right, guys. Well, that concludes this tour of NASA's JPL here in La Cañada, Flint Ridge, California. Hopefully you guys enjoyed the video. If you do, give it a big thumbs up. I know I enjoyed it. I had a hell of a time over here checking out this cool spacey stuff. Yeah, we didn't see any aliens, but that's okay. There were no aliens at Area 51 either. So whatever, it is what it is. Give it a thumbs up. Stay tuned. More OGP goodness coming back real soon with you guys. See ya. Want to see you. Bye-bye.